mk-table-checksum and mk-table-sync. So why would a slave get out of sync? So the problem in the first place is that the slave might be out of sync and you don't know. You might know, for example, if there is a column missing, replication might break. If there's a table missing, replication might break. But unless you, why would it get out of sync in the first place? Well, you might have writes to the slave. This is something that people do on purpose. They might have, their slave might be reporting ETL. So they're transforming on the slave. Or maybe they have, lots of writes to the master, and then the slave, they change data or they add a table so they can do reporting. Also, if you end up restoring a backup and then you start the slave at the wrong binary log position, I've done that because when you do a show slave status, there's the read position and the execution position. So sometimes I've done it from the wrong binary log or binary log position. And sometimes statement-based replication will, if you have the data a little bit out of sync, statement-based replication can get more out of sync. For example, if you're doing an update with a where clause or delete with a where clause, if the return of the where clause is different, if you're updating things, you say update where the date is between this and that. And if you start out with a little bit of different data, you can end up with a lot of different data because it's just updating the statement. The statements are just updating whatever matches, even though there may be different numbers of matches. There can also be non-deterministic writes. So deterministic means you run it the same, you get the same answer. 1 plus 1, no matter how many times you do it, is always 2, right? But if I say, what's the time right now, the answer is going to be different depending on what the time is. Now, there are such non-deterministic writes. MySQL does do a few things to make sure that some things are not non-deterministic, so that they are deterministic even though they're not normally. For example, if you say select now or select current timestamp, that's actually deterministic because in the binary log, MySQL puts the time. So if your servers are different times, you shouldn't get different times. The exception to this is if you use the function called sysdate. Sysdate gets the time of the system. So that's actually deterministic. That's the exception to it. Things like random numbers, if you use the rand function, MySQL actually puts the seed into the binary log so that when the random is run again on the slave, you get the same number. Same with auto increment. So a few of the things that you would think when you hear non-deterministic are actually covered by MySQL because they're the big cases that always happen all the time. But there are functions and things like that are non-deterministic. So that's another way that the data can get out of sync. And then there are things that are harder to prove. So slave restarted in memory table. Or if you are applying binary logs, and at the end of the binary log, let's say, there was a temporary table that should go to the beginning of the next one, but doesn't. Because once you apply the binary log and leave the session, the temporary table is gone. Or a slave restart. If there was an in-memory table and the slave stopped, then the session for the slave is done. So the in-memory table goes away. Dependencies on non-replicated data. So if you are joining two tables or something like that, you might not get the same table in sync. Non-unique server ID. So if you have the same server ID, the way that replication works, so let's say you have a slave and you tell the slave, pull from the master. Okay? The master doesn't care about the slaves. You can have 100 slaves, it doesn't know. It knows that there are things that are getting queries from it. The queries might be let me read the binary log, or the queries might be a select query. It doesn't know. So the way it works is it pulls from the slave. So you can actually have, say, a master, which is you have server A, slaves from server B, and server B, slaves from server A. You can also have a ring. Let's say A, B, C. You have A as a slave of B, B as a slave of C, C is a slave of A, and it goes around. Now, how do you know if you have this ring of A, B, C, or maybe you have 100? How do you know when you have a statement, right? It goes in gets written, goes to the binary log, then it gets written to B, goes to the binary log, then it gets written to C, and goes to the binary log, but it doesn't go back to A. So one of the ways replication works is if it sees its own server ID. So you have server ID 1, server ID 2, server ID 3. Server ID 1 writes a statement in the binary log. In addition to the time and the auto increment if there is one and the random, it writes the server ID. And you can actually see this when you do MySQL bin log. It'll say server ID. And so it says server ID 1 did this update. And so B, server ID 2, says, okay, server ID 1, great, let me take this and apply it. Because I'm not server ID 1, it didn't come from me, so I need to apply it. C goes and says, okay, well, I'm server ID 3, this is server ID 1, writes the binary log and goes. C says, okay, I'm 3, this is 1, I have to apply it. It applies it, writes the binary log, and then the A gets it again, right? So A is the slave of C, and it says, oh, I'm ID number 1, I don't need to apply this. So that's where the chain is broken. It goes all the way back to A, server ID 1, and server ID 1 says, I'm not applying it. It came from me. I have it already. And so then it doesn't get rid of the log. Otherwise, it would go forever in the ring. And I've had this happen. So if you have a server ID 1, and then you have server B is server ID 2, and then server C is server ID 1, it will go, and then it won't apply to C because it says, I'm server ID 1. I don't care. It's mine. So that's why you can have things that are different. And this happens a lot because people will have, 2 separate master-master pairs and then make a 4 ring. So it's 1, 2, 1, 2, and then, they end up losing half their data. So these are different ways that it can be out of sync. Some ways are hard to tell, like network errors. If a packet is dropped or something, if there's no error in the error log, how do you know? If there was one statement that wasn't applied, how do you know? You might know because your foreign keys suddenly don't work. They worked on the master but not on the slave. You might get, the regular replication errors that you might get, but if replication doesn't break, how do you know? You don't know. And also MySQL bugs, which has happened before, that, if something just isn't applied correctly or something. But that's hard to pinpoint. You kind of have to rule out everything else and do that. So, syncing the slave. The process that I do, and everybody does, different things. I find what's out of sync and which tables are out of sync, using mk-table-checksum on the master to replicate down. And then I figure out what the differences are, and then I will fix it, because it could be an easy fix or a hard fix. You don't know. I'm going to show you the example in a second. So the easy fix, it could be, for example, we saw someone using sysdate on their servers. They had one on the east coast of the United States and one on the west coast of the United States. So when we did mk-table-checksum, there was one table that every single part that we checksum was different. So when you do a checksum, you get the table and the part number and whatever, the boundaries, ID between this and that. And then you get the checksum and you can get a count. So the count was the same, the number of rows in the part was the same, but the checksum was different. So for all I know, there's one row in the whole thing that's different, or every row is different. So then I did a MySQL dump on both master and slave on just that part, just on the ID equals this or that, and then compared the data, and I saw that every row was different. I did a diff pipe into WC, and I saw every line was different. It wasn't one line different, it was thousands of lines. So then I looked, I said, okay, give me the first 3 lines of this file, the first 3 lines of that file. And I looked at them and I saw it's exactly the same, except the date is exactly 3 hours behind. And then I figured it out. And then I looked at I kind of took a few rows and I figured it out. So I like to do that. So and that's why I'm teaching you mk-table-checksum and mk-table-sync. You could just use mk-table-sync.
Giuseppe wrote an interesting article a couple of years ago about doing finding the rows that are different between 2 tables. He has a whole bunch of examples on something you can do. So instead of doing a diff, you can actually run it to help you find the rows that are different without having to do that table dump, because on most tables I'll find, but his example is on the huge tables, it'll be painful. So you should go back in his logs on his.
Okay, yeah, I'll ask him.
He has some interesting things on finding those different rows.
Yeah, what I do is I use chunks with mk-table-checksum.
Okay. Yeah.
So that I don't have to, it doesn't have to be the whole table.
Yeah.
And then the other way that I like to do is I like to do what I call continual replication sync checking, which is you run a chunk at a time. Like let's say you have 20 gigabytes of data, you're not going to checksum the whole thing at once, because even with chunks that would take a while, and replication ends up slowing down because you do one chunk and that takes a couple seconds, you do another chunk that takes a couple seconds, and it can take a long time. And you don't want to do it during your peak time because you're checksumming data. It's CPU, it's locking a few rows, not a ton of rows. And so if you have, say, 20 gigs, maybe you split it up into, 21 parts. You run it 3 times a day. So within a week, you will know if your data is out of sync. You won't know exactly at the same time, but within a week. And so it's continual because you keep going, and you use a modular and offset. You use modular 21, and so, the first day in the morning, it's, whatever, the afternoon or evening. Then it takes maybe 10 minutes each time, and everything's good. So this is an example of how to use it, because one of the things, and I'll say it now because if I say it then I have to commit to it. Giuseppe mentioned that, you know, what would be really good is a book about MathKit with a lot of examples of how to use it, because if you've tried to use it, the manual is very much like a Unix man page. Sometimes it's very hard to figure, like you can see all the options and what they do, but it's kind of hard to figure out for what you want to do, which options do you need, and will they work, and will they work together. So that's why I have these examples here. So Perl mk-table-checksum, or you just call mk-table-checksum. I'm doing localhost -u username -p --ask pass, so I don't have to write it on the thing. This is on the master. So the localhost is I do it on the master. --replicate matkit.checksum. What this does is it says you're going to replicate, so it means you're on the master, and you're going to replicate the statements you do down. And it has to be statement based, and I'll explain why in a second. And the table you're going to use is in the database matkit, the table called checksum. You can use any table you want, any database you want. We usually have a matkit database because there's other tools that sometimes, you know, want a table, like a heartbeat tool wants a table. So it's just easy to have a matkit table because you want to make sure for people who are maybe skipping some databases in replication, you want to make sure that they're, you know, replicating this. So this is what I do. So you can also specify chunks, which is what I do. And so to create this table, you want to create replicate table. So I have this replicate matkit checksum, but I want to create it because it's the first time I run it, or maybe I don't know if it's created. So create replicate table. If you don't have a table, we'll make it. If you do have a table, nothing. You can also, it uses, so on your first run, use create replicate table. If you chunk it, which is what I recommend, otherwise you're going to do the whole table in one chunk, which will lock the whole table, and you might as well do checksum table. There's actually a command in MySQL, checksum table, X, and you get the checksum back. Now, one thing I should specify, so checksum table, there's actually, if you're using MyISIM tables, I know most people are using Unity, but you would have to say this, if you're using MyISIM table, you can specify in the create table, or you can alter the table, the parameter checksum. So you can say, you know, alter table, MyISIM table, checksum equal 1, or create table, and then the create statement, checksum equal 1. And what that will do is it keeps a running checksum. So that if you do checksum table on a MyISIM table that has this, it comes back very fast. You're not locking anything because it's a running checksum. Every time you update, you know, it's exact metadata, just like the rows. Every time you update, it updates the number of rows, it updates the checksum. So that's a really good feature. It's usually a moot point because usually you're using a big DB transactional table. So if you're chunking, it uses an index to chunk it. It uses a numeric index. Okay, now numeric is also date or time because really they're numbers. But if you have a character index, because some people have a UUID or GUID, or you know, a hash or something, it's not, mk-table isn't always able to use it, and usually does not. Otherwise, it locks the whole table. This is in older versions, so I ran into this problem. If you did not have a suitable numeric index, it will lock the whole table. What they've done now is they realize that's a bad idea. And what they've done now is if you have a table that doesn't have any appropriate indexes, it just will skip checksum on the table. And you can have an option, no, I do want to lock the whole table, but there's no real good option to do it. So chunking and modulo. Chunks use numeric indexes, as I said. There's a modulo and an offset. So modulo is like the modulo operator. So if you say, you know, 21 modulo 5, the answer is 1, right? Because that's the offset, right? So if you divide your data, like I was saying, 20 gigabytes or 21 gigabytes, you want to divide it into 21 pieces. There'd be 1 gigabyte each, and it uses that. So this is how you would use it. So we've already done this replicate matkit checksum. You know the first 2 lines. The chunk size is 1,000. That's 1,000 rows. Modulo is 21. Offset is 7. Now the modulo could be different. Offset is 7, just starts at the 7th line. You can say start at 1, 2, 3, 4, you know, start at 0, start at 1. You can do that, and that's what you will end up doing. But as you'll see, you'll end up writing a script that just does this, increases the offset to 1, you know, by 1, and then keeps going. So this is how you do it. So what's chunk size 1,000? It's 1,000 rows. Now, this is based on numeric index. If your numeric index is a flag and it's 0 or 1, it's not going to be able to check 1,000 rows. It's going to have to check half of the rows because it doesn't know where it starts and stops within the index. So you have to have a very kind of balanced index as well. And the chunks aren't exactly 1,000 rows when you say 1,000. It's just that's approximately. So you might get 700 rows, you might get 1,200 rows. You might get 5,000 rows. I mean, if the index is a flag and the value is only 0 all the time, you can't split it up. So, like I said, chunks may not be exact, and there is no warning if there's no numeric index. This may have changed, but yeah. That was more difficult when it was locking, but again, you also don't want to be running this and think your data is in sync and realize it's skipping a table and you didn't know. There's also chunking and filtering. So if you chunk and filter, so you might say, look, they have this, I read the manual page, and they have this --since and --since column. I want to use it. You can do that as well. You can say for these tables, db.foo and db.var, I want a chunk size instead of modular and offset. Maybe all of your tables have a modified or created time, and you want to say since now minus interval 1 hour. Maybe write it every hour. So instead of having an offset and a modulo, this is because the offset and modulo, if you have 21 as your offset, it goes to the first table it finds and divides that, says, okay, what's 21? What's 21? If it's 2,100 rows, it'll be, like 100 pieces, and it will do it in chunk size of 1,000, so it'll be one chunk of 100. But if it has a lot of rows, then it's going to be bigger. So it's very hard to control how big your chunks are because you would have to do it per table. Which you can do, but that's a lot more complicated because then you have to go to every table and say, okay, how many rows in this table, how many rows in that table. So I prefer to do it with a modular and offset and just make it so that it's small enough. Because 1 gigabyte usually takes about maybe 10 minutes to checksum and replicate through. And you can put sleeps, mk-table-checksum has a sleep thing, you can put a sleep of a few seconds to let replication catch up. So that you don't end up being 10 minutes behind. Or you can do like this. You may only have, there may be some tables that you know are higher transactional, some tables that really, you care that your sales table, right, is the same data. And maybe you don't care so much the customer's data. If the email address didn't propagate, it doesn't change so much, it's probably right. You can check it once every couple months, but your sales data has to be, always right. So your sales has a time. So you can do that, and you can say since column modify date. So you can specify which column. And you can specify since when, basically. You can also do a --where. So you could say replicate mk-checksum chunk size 100 where modified date is greater than now minus interval 1. Now obviously, if you had this, this is the same example, why would you use one over the other? You wouldn't in this case. It wouldn't matter, although there's a caveat with the where. But if you had something where ID is greater than 1,000, or you can put anything in the where clause. So you can also say, hey, you know what? It's really this customer seems to get data out of sync all the time. So it's really where customer ID equals X, or you can do anything with that. Now the caveat, which I don't think I didn't have the query. I'm going back. I'm trying to go back. There we go. The one caveat that I found recently, only a month ago, maybe, probably right before I finished these slides, that I should put in here, is that if you're using the where column, the where clause, the chunking happens first. So for every chunk, it will apply the where clause, which is a little anti-intuitive. If you have a huge table, right, especially, that's not how it works with since, because it does it the right way with since, but with where, how does it know how many rows it's going to have? And even once it does, if it applied the where clause first, how can it break things up? It would have to do a count of how many there are, and where would it store things temporarily? It would have to store the row IDs in each one, and it would be a mess. So it's something that I didn't think about until I realized, why is this taking so long? We were doing it now minus interval 1 hour. It's taking forever. And I said, why is it? It was taking 6 hours to do this on a table. And when I looked, there were like 100 rows. So why is it taking 6 hours to find 100 rows? And I realized that it was, and I ran it manually, and I saw it with verbose, and I saw that it was doing every chunk. So it was every chunk in this huge table. It was looking, does this have any modified date greater than that? No. Okay, does this have any modified date? No. So it was, that's a caveat about the where, is that it's there. And it's not an easy fix from what I can understand, because I don't understand how you would fix it. But there you go. So how do you actually find the out-of-sync data? Right? You've run mk-table-checksum, you've let it run. Now what? Do you get a page right away? Does it magically know? No. You have to query the slave. So here's the magic of mk-table-checksum. Now, one of the things that I said was if you have non-deterministic queries, you can get different data on the master and slave. The genius of mk-table-checksum is that it uses that fact to make this table. So you have this table, mk-checksum, which replicates, and there are a few columns. There are a few columns in it. There's DB, database, table, boundaries. There's a chunk number, 0, 1, 2, 3, whatever. Master count, this count, master CRC, this CRC. CRC is the checksum. And there's a timestamp, TS, things like that. So what happens is on the master, the way that it works is on the master it says, what's the checksum of this, this chunk with these boundaries, whatever. And it comes back, and you have the hex number, the checksum, and it inserts the number into the table, into master CRC. So what the query that replicates is insert number into master CRC. Then it says, okay, what's this? What insert into the table with this CNT and this CRC, the count and the checksum. And that statement replicates. So the statement itself replicates the slave, and what you get on the slave is the master is what the master was, and this is what the slave is. So it's using the fact that you can have difference on the master and slave. Now, if you're using row-based replication or mixed, it will still work because it specifically sets the session to statement-based replication when it does that. So you don't have to worry about that. But it's ingenious to me that they use, the reason it gets out of date is the way that you can find the fix. Because you may have a different count on the master and slave, you may have a different checksum. So this is what I usually do: database table boundaries, master count, this count, timestamp, where this CRC does not equal master CRC. Show me where the checksum is not the same. You can have the checksum be the same, but very rare collision cases. And the database is not MATKit because obviously the MATKit database might be different. The tables in the MATKit database might be different. You also might not have database not in MySQL if you have different users, different grants. So the boundaries are the where clause, and here I have this is select star, so you see all the columns. So I said DB table, so DB is production, table is food, the chunk is 1176, you don't really care about the chunk number. Boundaries is ID is greater than this and ID is less than that. Now I didn't put that in, that's just, it did it, this is the chunk of 21 offset 7. So here's this CRC and here's master CRC, so you see they're different. You can see the count is different. There's 50 more rows on the slave than the master. And the timestamp, this is when the checksum was run, so you can see when the last time I pulled out an example for this, these slides were. So this is everything, but in here I said just database table boundaries, master count, and this count. Because, which is everything bolded, because even you trust that this CRC is different from master CRC, because that's the where clause. And it doesn't give you any information about how it's different. Just seeing the CRC. So I like to see this. And this will give you a nice, non-vertically formatted if you just get those rows. So once from here, once you've found the out-of-sync data, then you do your diffs, or you do whatever, and you can say, okay, show me, and you can do a MySQL dump with --where, and put this in the --where clause, so that it only exports that data. Or you can say select star from production.foo where ID equals, ID is greater than or less than that on both and compare. So continual replication sync checking, which I was talking about before. You have a dynamic offset, you have the modulo and the offset. So here again, you're familiar with these lines. And modulo 21, chunk size 1,000. Now the bottom offset, instead of saying 7, which is what it said before, the offset is actually the end of something that begins with select. So you can put anything you want, any select query you want. And if you say offset 7, it would be select 7, which gives you 7. So here, it's select modulo offset, which is the name of the column, from mk-table-checksum modulo. So I made a table called mk-table-checksum modulo. It has one value, one row in it, one column, and it's whatever the number is. You can run it from cron look on the slave regularly for differences, and you can make a, oh, I didn't show you the script. There's, after this, you would run a query that says update mk-table-checksum modulo, set modulo offset equal to modulo offset plus 1 mod, whatever the modulo is, mod 21. So basically you would run this, and in cron you would have this, and then you would have the insert into MySQL. That would be your cron. So that it will go through, and whatever you put in your cron, however often you run it, or whatever, you have to do those calculations. So if it's 21, do you run it once per day? And so within 3 weeks you'll know if a data gets out of sync, or do you run it 3 times a day? And maybe you run it 3 times a day at midnight 1 and 2. You don't have to run it, it's whatever interval you want to run it at. And you can make a monitoring script, like a Nagio script, to query the table and say, are there any rows that are different? So it would query the slave. So the cron runs on the master, and the slave runs there. And I've written checks that do that. And they'll also check to make sure the slave is getting the information. So make sure the slave is no more than 1 day out of sync. You know, if the last timestamp from this table here, with the timestamp, this last timestamp, this TS, if that's more than a day old, then checksum's not running. Assume you're running it at least once a day. So that's what I would do to just check. But the real work isn't the checking. The real work is figuring out what the difference is and making sure it's not something in the code. More often, we have found that it's something that we either can't figure out why, or it's something that when people flipped from a master to a slave, they were still writing the master and it never got to the slave. You know, but that happened years ago. And so every time they flipped, they lost a little data here, lost a little data there. So once you get the initial kind of cleanup done, it's interesting to see, okay, now what's being out of sync, now it's being out of sync. And it's usually due to something systemic, like using sysdate instead of using, you know, timestamp or now. Or it could be systemic that, oh, we didn't realize this was always writing this one database, no matter which was the master, it always wrote to this. Some things are hard-coded. So now what? You have to figure out why the data is out of sync. All the reasons we talked about before, find the differences. So here's MySQL dump on master and slave. This is how I usually do it. I might look at the data itself, but it's easier for me to do a diff. You can do skip extended insert, which means it's going to be the extended insert takes rows and batches them together. And you get these huge lines. Skip extended insert, you're going to get 1 line for each row, which is easier to diff because you want to know how many rows are different. So you would say dash where, I already said, we use diff to find differences. Again, we can also look up Giuseppe's blog and see what he did. So fix systemic issues. So I was saying sysdate, there's actually a parameter in MySQL called sysdate is now, meaning don't use the system time. If somebody says sysdate, just use the same thing for now. So use current timestamp. And then this way they didn't need to change their code and find all the sysdates. We just, I think at this point in time, I don't need to get the new version of Firefox right now, really. That probably means the page is loaded that we were looking at before. So instead of changing all our code and finding sysdate, we can, I think at the time we were doing it, it was a static parameter. It might be dynamic at this point. But it was a server variable. We just restarted the servers and everybody was happy and things were happy again. Rogue scripts. This is another thing we found. There were scripts that just hard-coded and always wrote to one server. Even if you switch the master and slave. They were directly going to the database. It wasn't using an A record. Right? So when you switch from a master to a slave, if you have master and you have a primary write master and you switch, there's different ways to do it. Some people have a code, like a configuration for their code to do it. Some people use DNS, where they point their writes to DB write, and when we need to flip from one to another, they change DB write to, you know, in DNS. Everybody has a different way. So sometimes there's a road script that will connect directly. Deterministic info, as we said. And so how do you fix, you know, some things you might need to use row-based or mixed binary logging. If you have deterministic stuff, that is just going to be deterministic. That's just the functions that you happen to have, you have to do it that way. You know, there's no real way to fix it other than actually fixing the issue, you know, not using deterministic. You might need to use row-based or mixed binary logging, which is, it's not really row-based or mixed replication, it's the format in the binary log, so it actually is replication, but it's a weird terminology to say row-based replication It's really row-based binary logging, and that's what it reads, but it's the same thing. The other thing is there are some things, for example, float precision. The whole point is it's not precise. It's not going to be the same. We actually had this might be, is it the next one? No, it's not actually. It's kind of surprising. One of the things we ran into was that the floating point numbers were different on the master and slave. And I think it wasn't just like the random, hey, it's a float point, so it doesn't matter. It was the versions were one minor version apart. One minor version. So one was 5.1.22 and one was 5.1.23, and they rounded differently.
So the floating points program only come up with the floats and MySQL.
Right. But it will come, the checksum will be different.
Yeah, but MySQL from the suggest not to use floats.
Right, for that very reason. Use a decimal if you want that. But these people were already using it, right? So I mean, when you go in and you do it, I mean, you know,
Okay.
yeah, these are things we found when we were running it on clients. Is that it's not that someone like a rogue script could be like, oh man, that person is stupid. It's not stupid to use a float, but it's float precision. That's what it is, right? You might not get the same thing if you're doing whatever. In this particular case, this happened to be something. This was a cloud computing service, and so they needed it because it was like billing. I mean, even though it went out to 6 decimal places or whatever, it was important that it's the same because they needed to make sure that if somebody went to a report and looked at the billing on, you know, and then the next day they went and did a report and looked at the billing, it had to be the same. But there's also so what we ended up doing is there's a parameter in mk-table-checksum, an option that says you only look at floats to this many numbers. So we said only look at floats to 2 decimal or 3 decimal places because we're rounding for money. It doesn't, you know, I only need 3 decimal places to have 2 decimal places for money, at least in US dollars. So that's the kind. It was interesting to see because we weren't sure what kind of things we would see. We weren't sure if we would see a lot of different data. Maybe replication just works, and maybe it's not so much of a big deal. But a lot of the stuff that we found was just we don't know how to explain it. There are some rows different on a master and a slave. Some rows had a different, you know, they were updated on one and not the other. We don't know why that happened, so we fixed it and then looked to make sure it didn't happen again, and lo and behold, it didn't happen again. So we guessed that it was when they did the master and slave, some writes didn't get to one of them. So fix the data by hand if it's easy. For example, this is what we had to do: update table, set the time field equals time field plus interval 3 hour, or 1 equal 1. So we had to change everything to be 3 hours later because that was the one with East Coast on the West Coast. Use a backup if it's too difficult. Sometimes you just have to say, you know what, it's crazy and I don't know what is different and whatnot, but let's take a backup of the other server, hopefully the backup of the right server, if you know which one is right. But sometimes, again, you say, well, if the floating point precision is off, who cares? If one of them is right, so we'll pick this one, probably the slave, because that's where you're taking the backups from. So this one's going to be right, so we'll take the backup, we'll restore the backup. It's a good test restores. So if there's, the other thing is there's a lot of foreign key dependencies. We have one client that had tons of foreign keys, and we're like, okay, there's 10 rows missing on this table. Well, there's 10 rows missing on this table, but they, you know, the things that we tried to insert, they had parent keys that needed, and then they had parent keys that needed, and there were 2 tables that had parent keys needed. So it was like, this is ridiculous. We were going to spend 3 hours inserting 10 rows because of all the dependencies. So, or you can fix the data with mk-table-sync. You can run mk-table-sync on the slave or the master. I usually like verbose mode. You can also do --print, --replicate if you run the master slave. So --replicate will actually take, instead of doing the checksum again, --replicate with the table that you give to --replicate in mk-table-sync assumes that it's the checksum you've done. So if you're in a situation too where you don't want to sync the entire database, but you know there are certain tables, well, there's also --tables and whatnot, but you know, if you're in a situation where you have like the 5 most important tables, you check some regularly, and then you say, okay, this is really complicated, let me just run a table sync. Instead of recalculating it, it goes by what's in the heartbeat.checksum table. So I presented it this way because this is the way that I think, for me, is the best way to do it, because theoretically, you should be doing the checksum anyway. Whether or not you do any syncing, right? You should do the checksum to see if it's not in sync. And so, let's say your data is fine, your data is fine, your data is fine. Oh, one day, there's a table that's different. So now, you can run mk-table-check sync with what's there. So now you have here, you have the replicate heartbeat.checksum table. H equals master host. This is a DSN. H equals master host equals user equals pass. Now print and verbose will print out what statements, will print out what statements it will run to fix the data. I like to look at this because you never know. Early on, mk-table-sync was not very reliable at all. I would run this, and I'd get run.me.sql, and I'd look at it, some deletes and some inserts, great, okay. And then I would run me.sql, and then I would run the checksum again, and I would get the same or different things that are different. And I would run me again, and then I would do the table sync again, and I would get different things. So I like to look and make sure, because it's a way of double checking, right? If you create a user for someone, do you create a user and say, okay, here your user's created? No, you create a user and then you try to log in as that user, if you can. You know, if the host settings, if you can access the host room. It's double checking. So at first when I was using it, now it's a lot better. So here's how I do it. Now once I've done that, right, now it's more reliable. I say instead of well, I also do dash print to print out the statements, but I add dash execute to run it. And so instead of saying run me, I put it into this was done.sql. Basically, execute it, do it, I trust you, but tell me what you did. Just in case later on we need to know what you did. Tell me what you did. So there are other ways to use mk-table-sync. So the way we used it was we used dash replicate and gave it the table. We did not use a parameter called sync to master. And we ran it on the master. If you use it with dash sync to master, so this is what I had. The master is the DSN. Find the slaves and sync them. That's the example that we had. If you use dash replicate with sync to master, you're going to run it on a slave and it will connect to the master. So if you know that there's one slave out of sync, again, it's going to check that table that you give it with dash replicate, but it's going to connect to the master and do it. Now why would you do this instead of the top one? Well, the top one, if you have 100 slaves, or 10 slaves, or 3 slaves, you don't necessarily want to be locking them the whole time to sync this part of the data. So you might want to do it one at a time. Maybe take it out of service, maybe you're doing some other maintenance, maybe you're altering a large table, and then you run this and it connects to the master, and so one at a time you do it. There's also, without replicate, sync to master with one DSN. So one H equals host, P equals user, P equals password. This is assuming you're running on a slave, because sync to master kind of implies that syncing to my master, I'm on a slave. So it will connect to the master. It will connect to whatever the master is. So the DSN is assumed to be the slave. And it will say, okay, you gave me this host and user password, that's the slave, I'm going to sync to the master. If you have more than one DSN, so if you give more than one host, it's going to assume the first one is the master and the rest are slaves. So if you have 10 slaves, you can give 5 or 6, say 6 DSNs. The first one is the master and the other 5 are slaves. So if you did want to kind of do it but not one at a time, you want to do 5 at a time or 10 at a time or 2 at a time, that's how you can do it. So there's a lot of different ways to use it. And depending on what kind of maintenance you're doing or what kind of environment you have, that's how you use it. So that's actually really it. A lot of it is really just how to use. What are the statements that you're getting with mk-table-checksum, for example? What's the mk-table-sync, fixing the data, the dynamic offset that you're using here. And I know this is a short talk. Things like this, like actually getting, how do I use it? Here's how to use it. It's very hard to find examples of how to use it. There's thousands of ways to use mk-table-checksum as well. Like we were talking about sync to master, or replicate, and all that stuff with mk-table-sync. With mk-table-checksum, you can do one table at a time. In the map-kit.checksum table, in the checksum table, you can actually have, or not in this table, you can actually specify a table that will have rules on how to chunk different tables, which is very, very complicated, and I don't use it because it's very fiddly. But if you had, say, 4 tables, and they were vastly different, and you wanted to checksum them in very different ways, I would probably just run mk-table-checksum 4 different times with different parameters. But you could run it one time, giving a parameter of use this table, let's see, I can find out what table it is if Firefox is. So here's where you find it. If you go to poundinterview.com, there's a community, so you have appearances, presentations, projects, and white papers. So if you go to presentations, you can see a bunch of presentations. Some of them have YouTube, so we have verifying MySQL Slave sync using mk-table-checksum and mk-table-sync. You can download the slides today if you want, assuming that you have a network connection. So if we do mk-table-checksum and we go here, you can see I've been here before. Let's see. See, these aren't really necessarily great examples. There's a lot of dots in there. It took a very long time for me to figure out how to use it. Let's see. And there's different algorithms for what's used, whether it's a CRC algorithm. Let's see. And you can actually run a checksum without -- replicate, without putting it into a table. You can just run it, say, from the slaves into the master, or from the masters into the slave, and just get the checksums on the command line. What's different? Let's see. So yeah, I was talking before about if there's a lot of rows, like if you have a flag, you know, if you have a flag and you have 1,000, if you have 1,000,000 rows and the flag is 0 or 1 and it's half and half, you're going to do 500,000 rows. There's actually this chunk size, which we saw was 1,000. There's actually a chunk size limit, which by default is 2, which is if it's greater than chunk size times chunk size limit. So if it's greater than 2,000, it won't actually checksum that. It says it's oversized. So it didn't checksum that, because otherwise you end up locking half your table. Let's see. Various options. Table. There was a whole arg table. It's called arg table. So it can be named anything. It must at least have the database and the table name, which makes sense, and that's the primary key. And these other columns as desired. So you can actually put all of these things, and let me make it bigger. Oh, did that make it bigger, or did I just go somewhere? There we go. Yeah, this is making it bigger. So all of these things, algorithm, chunk, column. So you can actually specify which column to chunk on. Chunk index, you can specify which index to chunk on, which might be different from chunk column, because you may have an index with more than one column. Chunk size, so you have different chunks for each one. Which columns to do. Maybe you don't want to do your float column, so you want to do other columns.
Well, I have a question.
Sure.
What kind of performance implications does it do?
Checksum period or anything?
Checksum.
The checksum has some performance implications. What it does, and this is why we do the chunk size. If you just say, you know, mk-table-checksum is just going to go and check some of the tables. If you give it, you know, a chunk size and whatever, it's going to try to use an index. And that index, again, has to be numeric, and so it's going to try to get the right size. So if you say chunk size 1,000 and you have a good index, you know, it's on time or something, the 1,000, it's going to lock 1,000 rows, checksum. It's going to do like checksum 1,000 rows.
It locks it for write process?
Locks it for read. It's a shared lock.
It's a shared lock.
Because it just has to read it in time.
Okay, it's actually not imposing any problems to turn on an application that reads.
Well, it locks. So if you're using the -- replicate and you do it on the master and you're giving it to a table, right? It does that insert into the table. So you'll see it insert into, you know, map-kit.checksum, aspirin, later. Insert into you know, map-kit.checksum, select CRC from this table. You know, it does a checksum of those rows. So that does replicate, and it can make things fall behind replication. But you can have mk-table-checksum sleep between ones. So there's a sleep parameter, and it's called sleep. Yeah, oh, it's sleep and sleep coefficient. So you can actually change the number of times it sleeps. You can also have check slave lag. So if the slave gets more than a certain amount of seconds out of sync, wait until it's in sync. Which says it should eliminate the need for sleep or sleep coefficient. But you can also do sleep, so throw out sleep time between checks. So between each chunk, it's going to sleep. So you can have sleep coefficient I don't really use sleep or sleep coefficient, and so sleep is the multiple of the last checksum time. So if the checksum took 5 seconds, it's going to sleep, versus 10 seconds, it's going to sleep longer after 10 seconds because the idea is to wait for replication to catch up. It hasn't really been a problem if you have a size, again, if you size your chunk appropriately. I haven't found it to be a problem. And what you do is you run it once with the offset and modulo, and you run it by hand, you see how long it takes, and you see how replication slows down. And again, you don't run it on peak times. I mean, you'll figure it out. It's an art at this point, right? The implication is it will lock for read, but then it also does an insert. So how long it takes to do the calculation and then insert. It could get behind replication. So yeah, if you've just gotten your server to the point where it was falling farther and farther behind, and you optimized a few things and now it's good, this might bring it back to that. But it only doesn't run. That's how you choose how continually you want it to run. Do you want it to run every hour, or do you want it to run every once a day?
Okay, thanks.
You're welcome.